So I'm standing on the table of this machine. Gigantic.
So this is one of the biggest horizontals around. They'll do 47 feet. I think it was almost 600 yards of concrete in that.
Holy cow. Wow.
So
some big stuff.
Yeah.
Now this machine is freaking huge.
We can fit 150 inches under the ram.
You can't even buy one like this. Yeah.
The table alone is 128,000 pounds.
Wow.
So you have all kinds of cones, right? You have a little dish pad up top here. Cone. It's huge. It's the biggest one in the world.
We have some of the top guys in the company now want to become a sandblaster because
It was like the craziest thing. It was like Moses struck the rock in the desert.
yeah.
So that's a pump impeller.
Hey, thanks for watching my video. If you enjoy it and you could subscribe, like, comment, that really helps me out. And then if you want me to film one of these shop tour videos at your shop, it's totally free. So if you're looking for new employees, if you're looking for new work, it's great exposure for that. So reach out to me, here's my email, and enjoy the video. All right guys, so today I am in Phillipsburg, New Jersey. We're at GJ Oliver, and these guys do some really large capacity machining and fabrication, awesome huge machines, and they're gonna show us around. So nice of them to open up the facility, and let's see what they got for us.
We're a job shop. They can do big work. We do custom steel fabrication, machining, lube oil systems, seal gas panels. My father started the business in 1960. I took it over in 2008, so we run it as a family business. We have probably around 80 some people working here.
I'm assuming you started as a small fabrication operation?
Yeah, small fabrication shop. Then when I took over, we started with the machining and the loop systems, and we took it from there.
So yeah, this is the newest side of our machine shop. All of these machines have gone in within the last 10 years.
Now this machine is freaking huge.
We bought it out of PSE&G a couple years ago, but we had to retrofit it to CNC. It was an old one, so we redid all of it. So yeah,
so it has FANUC controls in it. We can fit 150 inches under the ram. This goes 30 feet deep.
Wow, below what I'm seeing.
Below what you're seeing here.
Yeah.
The table alone is 128,000 pounds.
Wow.
Like I said, all of the pits, everything that you see here was designed in-house.
Yeah.
Whereas a lot of machine shops will have to sub out, you know, foundation work and things like that. This was all done by us. The rebar was put in by our welders. The concrete was done by mechanics, welders, you name it. He dug the hole with the excavator, you know.
Okay.
Yeah, we do what we got to do.
Yeah, we have little dingoes in there digging dirt out. You know, we do what we have to do. You know, but yeah, this is 30 feet deep, and I believe it's 26 foot wide, and then it's filled with concrete, you know, and rebar.
Yeah. So this looks like another one of those old good iron machines that'd be hard to
you don't find
yep.
them like that. Not that solid. You can't even buy one like this. They thinned everything up, and it's not like this. This is an oldie but goodie, you know?
Yeah. So you said you retrofitted it. I see the FANUC servos and stuff. What was it when you got it, as far as controls?
No control, manual.
Manual. Like
Just
literally like
it's a manual machine. Yeah.
Wow.
Yeah, so they had two people running it when we went and looked at it before.
One guy was turning one guy was on the other side.
Yeah.
Yeah, they had two heads on it.
Okay.
We took the one head off completely.
Yeah.
And run CNC.
Now this doesn't look like it has a milling head on it, does it?
No.
Okay.
No, this is
that'd be a completely different beast to retrofit.
Yeah, that would be a whole nother.
And that's cool.
Yeah.
So did you have somebody come in and like re-scrape all these ways and everything?
Yeah, all the above.
Looks like it. You can see all the tool marks on there.
Yeah, everything was redone on the machine.
Did you have to have somebody come in from overseas to do that, or is there local companies
there's a local guy.
Okay.
Yeah, local guy come in and did it. Yeah, so that part we fabricated, and then it going through stress relief, and then he's machining it now. Yep.
Obviously, it's a very small part for a very large machine.
Hey,
But you know, again, this doesn't have a live head, so sometimes we have to, you know, throw parts across it that maybe aren't as critical on hole location. You know, whereas we would need a live head if they have true positioning on hole location, things like that.
Sure. But, it's funny you say, oh, it's a very small part. That's a huge part.
Yeah. It looks small on that table. Yeah.
Okay, quick pause in the video to tell you about my day job as a salesperson for Campro USA. Machining centers, turning centers, box and linear way, a bunch of different configurations. Currently at a customer in upstate New York that has 35 of them. I just walked around and checked. They have bridge mills, as you see here. They got boxway verticals. They got turning centers on the other end. They got horizontals in this next cell. They got 4 more coming. So these are legit machines in a legit shop. And if you guys are, if anybody's interested in machinery, I'd appreciate it if you give Campro a look. That's the best way to support what I'm doing with these videos. Thanks a lot for watching. Enjoy the rest of the video.
Another big boring mill. This is
If you come over here, you can actually get a shot. So
Yeah.
what he's doing now is he's going in and he's pouring out this split casing
Sweet.
back to spec.
the customer took it apart, sent the castings to us to machine.
Okay. So you guys are resurfacing
We
those spaces?
surface
Yeah.
it, and then we do the bores.
Yeah.
Yep.
So basically, so what we do is we got this as completely just torn apart from our customer. We went in and we opened up these bores that you can see he has the blue dye on. We opened them up. We rolled 410 rings. We tack welded them inside of there. Now we're machining it back to spec.
How did you get in there and cut those rings?
So he's going in there with a saw
Saw
Oh,
cut.
okay.
on a 90 head.
I was gonna say,
Yeah,
because
he
I
goes
can't
down.
really imagine.
Yeah, he's going in there with a saw on a 90 head, and he's interpolating that way.
Okay.
And you can't like, if that was a regular, that's a casting, so we can't weld up the fits. So we had to use 410 bar in there instead of welding, because it wouldn't attach the
Okay.
weld.
Gotcha. Interesting.
We tend to do a lot of these on our gantry mill.
Okay.
It's just that our
Which is over
gantry
there.
mill is tied up with another split casing, so you know we had to make it work with what we got.
That's why we're gonna buy another one.
For me.
Yeah, right. Yeah.
Yeah.
Maybe.
Yeah.
Yeah, cool. Okay, so you
Yeah. So that's the top half.
gotcha.
Yeah. Or bottom half. That might be the bottom half. I'm not sure.
Yeah.
But yeah. So they'll go back together, bolt back together, and then your whole tolerances in the bores and make sure everything's right with
Yeah.
1,000 or whatever. Yep.
Neat.
On this, I'm not 100% on this specific casing. I don't know if he just touched on this, but a lot of times what we'll do is we'll do a blue check on these as well, where we'll put down like a blue compound and we'll bolt them together per our customer specs, whether it's, you know, to a certain torque range or, you know, sometimes it's every other bolt has to go in and make sure they're completely dead nuts flat and making 100% contact face to face.
Right.
I'm not 100% if this one calls for that yet, but we do that quite often with these
a
split
lot of times
casings.
you'll end up grinding it also
Oh,
to
yeah?
get that blue check, because
Yeah.
it just takes a little
Right.
bit for blue check.
You guys
Yep.
have big grinders over there?
So we'll put our grinders on this machine,
Okay.
and then we'll also mount a grinder on our gantry mill as well.
So this is one of the biggest horizontals around.
Yeah, no kidding.
I'll do 47 feet.
Crazy.
Yep. We got a pedestal on there. We fabricated that. Now we're machining it. That's a system tool, but it's smaller. But yeah,
Sweet.
that goes back, forth, up, down. We do a lot of big base plates. Like we can stand them up on their sides and mill and what.
Yeah, we'll bolt them to, you know, some of those angle plates, and then we'll be able to mill the pads and the feet and whatnot.
When I put this in, we had to take the excavator, pick it up in the crane, and drop it down in because it couldn't go down far enough to dig. And then we had another excavator to catch the dirt from that excavator to bring it out.
So how deep is this?
I think it's 20-some feet deep.
And then,
It's got to be deeper than that,
Yeah,
honestly.
25 feet.
Yeah.
I
so
don't remember.
you use this crane, lift up an excavator,
Yeah.
drop it in the hole.
Yeah.
That's funny.
Yeah. And that was, I think, I'm not positive, but I think it was almost 600 yards of concrete in that. That's 18, it's way deeper than that.
Yeah.
Because there's 18 foot of concrete in that,
Yeah.
in that hole at the bottom. So it don't move.
Do you remember how much this machine weighs?
Oh,
No. Yeah.
No.
Random number.
yeah.
Now, can I poke around here?
Yeah, that was 18 foot deep of concrete.
Yeah.
So I'm standing on the table of this machine. Gigantic. What is this here?
So that's for our. This is a rotary table.
Oh,
So this
okay.
is the controls for the rotary table.
Okay, so that's totally separate. Then.
Yeah, it's totally separate in this. Yep.
This is
in this
like
machine.
a add-on. This is just like kind of bolted onto the.
Yep. So like obviously we can move it if we have big base plates or something along those lines that we need to bolt across the whole length of the floor, or we can move the rotary table to one end or the other. Generally we use the rotary table a lot just because it's one setup in a lot of aspects. You can spin the table and things like that.
This one's only a year old.
Shibaura.
Shibaura.
Yeah.
Big boring mill.
Yep.
Yeah, we have 2 of them, both the same size.
Can we poke around this machine?
Yeah, absolutely.
Yeah, we can come up this way.
Okay. You got a big fixture plate on there.
Yeah. He's only doing a little piece right now, but you can see just
Okay.
milling it's a man-weight cover for something. Yep.
It's like a 6-inch or something quill on that. I
Yeah.
think that's how they classify boring mills. I think it's by the size of the quill or something.
Yeah, right.
That's the Fanic.
Yep, Fanic haulers are Fanic.
All right, so same Shibaura that we just saw over there.
Yep, same piece. Yep.
That's a fabricated part that we built 347 material as well.
Yeah,
That's now staged for machining.
that's staged for machining.
Okay, so
So we'll mill the flats, then they get bolted together, then it gets spun, and then all kinds of holes. There's all kinds of stuff going on with it.
you can see where the individual parts are, right?
Yeah,
so you
yeah, yeah.
fabricated this separately from
Yeah,
this, and then
yeah,
just welded
yeah,
it all together. and
yeah.
stuff.
All X-ray.
Okay, that's the white chalk.
That's
or
the white
whatever.
PT dust.
That's LPI,
Yeah.
PT. Mhm.
A big VTL here.
Yeah. Here's some
Toshiba.
nuclear columns.
What is a nuclear column?
Just a column for water
Okay.
Go into a nuclear facility.
going to a
Okay,
nuclear
but it's
facility.
carrying water through that.
Yeah.
That's basically what it
Yeah.
does, yeah.
Toshiba.
This here's a vertical. Live. They all have live heads on them,
Okay.
so you can drill, mill, all that kind of
Is
stuff.
that 50 taper live heads, I would assume?
Yes.
Yeah.
Yes. So can we open this? Oh, thank you.
Nice. So what's that, like 6 feet tall or something?
Yeah, yeah.
You're just boring out.
Yeah,
What
it's doing all the boring, and there's 2 halves here. They're bolted together.
What is this part, do you know?
It's inner barrel.
Inner barrel.
Yeah, it's an inner barrel for a compressor.
Okay.
Goes inside a compressor.
Gotcha.
Barrel casing.
Okay, and then you got your Cat 50 tool changer
Yeah,
here.
yeah.
Okay.
Thanks, buddy.
And that just tool changes like a machining center, I guess.
Yeah. Yeah.
Is it dual
Yeah,
arm?
it comes in, yeah.
And that puts it right on the end of the ram, same
Mhm.
spot where your turning tool
Correct.
goes, your
Correct.
milling tool would go.
Right.
Okay. Big Okuma bridge mill.
Mhm.
These are cool. MCR.
I'll tell you what, they're good machines.
Yeah, I know, because I compete against them a lot, so they give me
Yeah.
a lot of grief.
Yeah.
But I know they're good stuff.
But they only go so big.
Yeah.
So we're at Okuma because they don't make a big enough machine for us.
Oh yeah, what's the biggest one?
I don't know what it is, but it's not
Too
big
small.
enough. Yeah.
So this has got the right angle head on it,
Yeah, right now.
and you could obviously put a straight head on
yeah.
that.
Correct.
And the machine will change those heads themselves, right?
Correct, yeah.
And the cool thing about these, you can still automatic tool change into the right angle head and
Yeah.
into the straight head, right?
Right.
Yeah, a lot of right angle heads people put on, and then they got to manually load
Yeah,
the tool.
no, this is automatic.
Yeah, that's sweet. So is that okay, that's a 50 taper right angle? Okay. Can I peek up here?
Yeah,
Yeah.
yeah, go ahead up there. Yep, so this is a pump casing.
Sweet.
We drill the holes, you know, it was a casting that came in and we mill it, drill the holes, do everything. Then we're gonna do the bores now, and the other half is out here somewhere.
Yeah.
Yep.
Sweet. So these, it looks like you surface these with a vertical tool. And
yeah,
then
they're not done yet. It's just rough. Yeah.
Then you'll flip that up and go bore them or something.
Yeah.
Yeah.
Exactly.
Now these are all probably bearing diameters, right? So very critical.
Yeah, very
tight
critical.
tolerance.
Yeah. What's nice about this machine is I can put both halves up on it, and once I do all the boring, I can put them together, and I'm within 1,000. You know, the old days you ran a bar through there and you fly cut it, you know, and then you take that's way back when they had machines like this, but yep.
Yeah, this is a cool machine.
Yeah, it's a good machine. It's continuously running all the time.
10, 12 feet or something by 5 or something. How long have you had this Okuma?
I'd say probably 8 years, 9 years. Yeah. We bought it new. Everything bought new.
Yeah. So this was our original machine shop. From these beams, we had 2 of these verticals, and then the larger Simmons manual boring mill as well. As you can see, you know, that side we expanded into, and then we'll work our way over to that side as well. But this was specifically
This was original.
the original, yeah.
My dad used to. They built filters like little air filters on this side here, just from here over, and we got rid of that, and then we started with the machine shop.
Yeah. Sweet.
The machine shop was originally just to complement the fab shop.
Sure, yeah.
Y'all,
You know, bevels,
Pump a couple holes.
yeah, drill a
Tap
couple
something.
holes. Yep,
Yeah.
that's all it was originally.
Yeah, it's funny, this Okuma here, which is a very normal sized machine,
Yeah.
you could machine that machine.
Yeah. We could spin that.
Easy.
So this is another boring mill, and then this is a fabricated shroud that we built. It's currently just in its roughed in state, but it has 3/16 inlay for where the impeller rides inside of. So one of that big impeller that we looked at up top, that basically is flipped upside down and sits inside of this.
Okay.
And then it spins.
Right.
So then this customer wanted this shroud to be inlaid. You can see some of the inlay that's already roughed in.
So this,
Again, it's just rough, so there's still more material coming out of here, but.
Okay.
Yeah.
Man, I could spend an hour talking to you about each of these machines, but we kind of got to gloss over
Yeah, I know.
for time's sake, but yeah, neat. Okay, so that has a tool changer on the side that like shuttles around. Cool.
Yeah.
Okay, so a dual ram
Yeah.
VTL.
Simmons. That was our first machine we bought, you know. Come out of GE.
Okay.
Yeah. It runs.
Now that looks manual, right?
Yep.
Okay. So the rams will feed up and down.
Yeah,
and then
everything moves
they can feed
automatic.
side to side.
Yeah.
Yeah.
Yep.
Cool. Now, do you often cut with both rams at a time?
Not unless it's a big casting.
Why would you do that? Just faster material remover? Okay. Yeah, it doesn't seem like for such low quantities that's going to be much of a factor.
Yeah, nowadays everybody's buying stuff right almost to the edge, you know?
Right.
So saving material, so there's not much hog in there to take off. You know?
So when this machine was built, casting technology, forging, not nearly as advanced. You have a lot more material to remove.
Right.
That's 2 rams.
Yep.
Okay. Okay, so one ram will tilt and the other one is stationary.
Correct.
So different capabilities with the rams, but yep. Neat.
So the transition that he was explaining to you up in Fab Shop, that's this section from here down. So that's what this is, just on a smaller scale. This is what it's going to look like, just much larger.
And you're going to make this piece for it too?
Yep. Yeah, so he was just fitting from here to that flange up in the shop.
That's how big it is. This is like the baby of it. I think this is an E138 they call it, and that's an E156, which is a lot bigger machine. So yeah.
Which is funny calling this a baby when standing in it.
cool. Well, this machine is a little different design with the cantilever ram.
Yeah.
Not as much difference, or?
This has a live head on it and everything.
Okay.
You know, and this whole table comes out, it slides. So I can do 220 inches of diameter on this machine.
Yeah, we could swing that. Yeah, the table will extend out. So it won't hit the column from when we're spinning larger diameter pieces.
Okay, yeah, I can see that must be a ball screw under there.
Yep.
Interesting. So it's funny you have such huge machines, but you really don't end up taking probably huge cuts.
No.
Maybe once in a while, but
Not
like
much.
we were talking about with the casting and such, you're really just hitting a couple critical spots on these huge weldments.
Correct.
Right.
He has an impeller on here, like
Okay.
the one that we were talking about.
Watch it, you're gonna get wet a little bit.
Okay.
It might shoot out.
That's all right.
You can see it. So that's a pump impeller.
Yeah. So this is one where you said you had to punch the hole in and bore it.
Yeah, this is a smaller one.
Yeah, this is a raw casting that we're making a brand new impeller for.
Okay.
The one that you saw up there was a refurbished one that we were repairing to put back in service.
How do you put the keyways in there? Do you like put a brooch in
We
this
broach
ram?
them. Yeah, we have a key seater.
Yeah.
Okay, and that's a specific machine that
Yeah,
you broach
that's all
it?
it does.
Okay, yeah.
We have two machines. We have one for a smaller and one for a bigger.
Yeah.
So that's a machine shop.
Yeah, that's a machine shop, I'd say.
So the customers, they like coming here because we do it all here, you know, and it's family run. They call me or my son.
Right.
You know, they don't have to go through all these kind of people.
Yeah, not some big corporate
Yeah, right.
bureaucracy slogged down in paperwork.
Right, exactly.
For as big of a business as you are, to still operate like a nimble family-run company,
Yeah, exactly.
that's pretty unique.
Yeah, we try.
So my name's Andrew Allen. I'm Director of Engineering here. I've been here about 13 years with the company. My job is basically, you know, customers sometimes don't really know what they need. They have a problem, but not a solution. So my job is to kind of find a solution for them, work with the tools we have and see what we can do. A lot of times we have, you know, older parts that are kind of, you know, documentation doesn't exist really anymore and they're worn out, and they'll send it to us and we'll take complex measurements. We have a lot of equipment. It's a scanner that will actually record the entire piece live for us so I can extract information that I need. The scanner has a 0.1 millimeter accuracy and it shoots 80 frames per second. It doesn't have enough for machining fits. When we need that, we bring in the ferro arm. It does much better for that type of things. But pump parts such as impellers, it does a great job capturing organic shapes that are really difficult to measure.
Okay. There's a pump part in some facility that's been there for 80 years and now it needs to be replaced. There's no 3D models of it because that didn't exist at the time. They slap it on here, you can come up with a 3D model.
3D model, fabrication prints, whatever they need.
Sweet.
And we can even build it for them.
Nice.
And basically what it does is it takes a ton of pictures and it knows where it is to be able to stitch together the model for us. And it's a live image.
Yep.
So I'm not capturing information yet, so it looks a little bit pixelated. Hopefully there's enough room for you to see it. Start the scan process
Oh yeah.
and just walk around it.
Just spraying it with light, huh?
Exactly. It's taking all the information I need in, you know, basically a couple of seconds that I can take that in, import it into my CAM software or CAD software and develop machine code, models, whatever we need to do for the customer.
Sweet. That's pretty cool. And you said it's a 0.1 millimeter accuracy on that?
Single point resolution is 0.1 millimeters, so it's very good for a lot of things.
Right, okay. And then a ferro arm, which actually has a touch probe, right, would be kind of the next order of magnitude of accuracy.
So the ferro arm, we have a couple of assemblies. We have the touch probe and the laser tracker, which is basically you set it up on a tripod and you put little sensors and it tracks it. It articulates its head. It knows exactly where it is. The accuracy on that, I believe, is 10/thousandths of an inch.
Okay.
So perfect for, you know, machine fits or complex geometry, or not complex, but precision geometry.
Yeah.
So this is a nose cone for expander casing.
Okay.
It's all 347. So it's ready to be machined now. We fabricated this whole thing. It was all x-rayed. penetrant tested. We made the vanes that go inside for cooling. So you have all kinds of cones, right? You have a little dish head up top here, cone. They all have to be ground smooth
Cool.
for the air.
So, I mean, I could imagine something like this on the front of a airplane propeller and things coming out of here. But that's obviously
It's like a jet engine that's blowing down through here. You know what I mean? So
Okay.
yeah, it's kind of like
Similar?
that. Yeah, it's similar
Dealing
like that.
with,
It runs at like, I'm not exactly, but like 1400 degrees all day long. That's what it runs at. So
in some kind of power gen facility.
yeah, exactly.
Okay.
All right, so you said this is the prep shop. So I'm assuming that implies you prepare jobs here. Okay.
Yeah, this is where all the raw material comes in. From here, it's checked in and it is prepped based off of what needs to be done to the job. So we have a 600-ton hydraulic brake press behind us. We have a 340-ton mechanical brake press, as well as a 150-ton mechanical brake press. And in the back there, we have a 500-ton horizontal bender and straightener as well.
Mechanical, hydraulic. Yeah. Spins a big flywheel, clutch engages it, moves it down on the piece. Hydraulic cylinders.
But this is a horizontal bender.
Okay.
So this is, like I said previously, this is a 500-ton. What we will use this, it's used for multiple things. Whether it's straightening something that made of warp from welding, this arm basically comes out and will then straighten out whatever part you're putting in here into the dies.
Okay.
So this arm extends out running off of these levers.
Maybe a big shaft is bent or something and you just need to straighten it up. That's right.
Yeah, it could, yeah. Usually it's not. Usually won't be like a shaft because those are usually finished machine.
Okay.
But if it's like a a longer fabrication
Or an OD/ID ring that gets
if it
warped, you can
works.
take it in there, stand it vertical, and you can just push it and bump it to make it straight.
Gotcha.
Yeah, before you fabricate it or whatever.
A big smasher.
yeah.
Big straightener, basically.
Yeah, okay. Yeah, it looks heavy.
Yeah.
And you got some big cranes for handling the material
Yeah.
and stuff. Another big roll here.
Yeah.
Yeah, so this is a plasma and an oxy-fuel burning table. This machine also has an articulating head, so when it's cutting, it will articulate and it'll put bevels onto the plates. So you're not hand beveling plates.
Okay.
You're doing it on the machine, and it's all programmed into our office in there, and it's sent directly to the machine.
We could put 4 sheets on it. 96 by 240. So if you had to, you could put 4 sheets on and burn 4 sheets in one shot. 96 by 240.
Wow.
Yeah,
I'm assuming that's as far as these things go, that's a big one.
that's a big one.
Okay.
Yeah, that's a big one.
Nice. And then these are obviously plates that you're burning on here.
Yeah. Like this shop is all preparation, like we said before. So we'll get the drawings. We'll basically prep everything, make cones, whatever, burn flanges, whatever we're doing. Then it goes into the other shop, which we're going next. They fit, weld it, and then once that's done, we have a heat treating oven. Goes to heat treat if it calls for heat treating, and then it'll go to our machine shop.
All right, so now where are we headed?
We're going to the fabrication shop,
Okay.
where we put stuff together and weld.
27.5-ton crane. That's a lot.
Yep.
Holy cow. Wow.
So
Some big stuff.
yeah, we do pump repairs. This is a pump repair casing that has vanes inside it. A lot of people bring their pumps here. We'll take them all apart, put new bearings in, check fits, all that kind of stuff.
And then this is just some kind of flat table to
For fitting.
referencing.
For fitting.
Okay.
We'll put everything together on that table so it's flat. That's an expander casing for a expander job, and that's the outer exhaust where the flue comes through. It's huge. It's the biggest one in the world. It's gonna be the biggest one.
Okay.
Good. Yeah.
So subarcing, what is that?
Basically, it feeds one automatic welding machine,
Oh,
and what you do is you don't even have to wear a helmet or anything. It's covered by flux as it welds, but you can put a lot of weld done at one time, which you can see some of the welds here.
So this is on big rollers, as you can see. So as he's dumping wire, the part is spinning on the rollers to keep up with the feed of the wire coming out.
Cool. Automatic.
Wow. So this is obviously all synced up and.
Yep. Yeah. Showing some up close of the welds.
Yeah.
I don't know much about welding, but that looks like a nice consistent weld.
Yeah, it does consistent welds, yeah.
That's huge.
Oh, yeah. Our strong thing is we do a lot of NDE work type, X-ray welding, mag particle, that kind of stuff.
So some real critical application.
Yeah, that's what we do. We're doing a lot of, now we're doing some nuclear work.
Have you seen an uptick in the nuclear stuff?
Yeah, a lot.
Just in the last few years?
This last year really took off for us. So we're doing quite a bit of that kind of stuff right now.
Yeah, so to piggyback off what he was talking about with our NDE that's done on a lot of jobs that come through here, whether it's 100% X-ray, UT. So we sub those out to a local company, but we have our own staff here where we're certified to do mag particle inspection, PT inspection, CWI, and we also have a PMI gun for identifying materials as well. So a lot of times inside of these shops, those specific quality control employees are in here doing those testing. And it's all dependent on what the customer wants, whether they want X-ray, whether they want mag particle, UT X-ray, things of that nature.
Yeah. I don't know what a lot of those mean. X-ray, I think I understand.
Yeah.
Tell me about some of the other ones.
They're inspecting the welds, right? They're looking for defects inside of the weld, making sure you have 100% blow through. There's no porosity, there's no slag, there's nothing in that weld showing any defect whatsoever. Now with PT and MT, what we do here, that's more of on a surface level. It's picking up little holes, undercut, cracks if there's any of that. But when you get more into the UT and the X-ray, they're shooting through that weld and they're specifically looking for defects. Yeah. And just the material in general. Sometimes we'll have customers who want, if we're building a base plate, they'll want, the tubing of the base plate where the lifting lugs are going to be welded, they want those UT, before we even weld it, just to make sure there's no defects in the material prior to welding. So, and that's all subbed out. We don't do that in-house.
Gotcha.
Yeah, we do everything but X-ray and UT.
Okay.
Everything else is in-house. LPI, which is PT, mag particle, we do everything here. We're certified.
Yeah.
We're certified even in a nuclear for PT.
Gotcha. I imagine there's not many fab shops that have this kind of capacity, so I'm assuming you're sending work all over the world?
All over.
Okay.
Yeah, we don't even have a salesman. We go word of mouth, so we got, maybe 10 or 15 really good customers that just keep coming back to us. So,
So
we don't push ourselves.
Yeah.
The capabilities of this, fabricating this material, but then also being able to machine it on one site is big for us.
Okay.
We're not, if a customer comes to us and they want something built, they want something machined, they want something post-weld heat treated after building it prior to machining, sandblasting, painting, like it's all done in one location.
Correct.
On this 22-acre campus.
Right.
It's all done here.
So that's probably big for some of the stuff like nuclear and more critical work because you can control the process end to end.
Correct.
Exactly.
Correct.
Yeah.
And we have project managers that run through each job. We have a certain project manager for that job. So, when the customer gets an order, or we get an order from the customer, they get the project manager's name and everything. So that's the guy to talk to if there's any problems and stuff like that.
Yeah.
Yep.
So this is just another assembly table?
Another assembly table.
Okay. That's what you call it, assembly table?
Yeah,
okay.
fitting table, really.
Fitting table.
In this bay, this middle bay here, we have two overhead 10-ton cranes. So we have another fitter in this bay. And If you look down, here is our sandblast booth that we recently put in.
Yeah, that's huge.
Yeah.
Yeah, we just put this up last year.
Yep.
Put the building up and everything.
So what he's doing here is, so along this side of the building, that's a trough on a conveyor that runs up through and recycles the dust and the used media and recycles it back into the system. He has 2 hoses, like I said before, one for brand new media, which we use on stainless steel because we don't want recycled media with iron or carbon to contaminate the stainless steel.
End up getting like a surface rust on it.
You impregnate the material and then things rust, and we don't want that.
Right.
That's not a good thing.
You'd have to passivate the whole thing or something.
Yeah. And his hood actually has air conditioning in it, which is, sandblasting is, it used to be one of the worst jobs here just because of, it's a very physically demanding job. Now it's one of the most coveted because he has air conditioning. So
He's the one that has air conditioning.
we have some of the top guys in the company now want to become a sandblaster because
Maybe I could take a spin at that.
yeah, there you go.
We do a lot of impellers.
Oh, wow.
That's a pump impeller. What we'll do is this one's a used one that came in on a pump. We had to take the shaft off, and now what we'll do is we'll do all the NDE on it to make sure it's not cracked.
NDE is just an inspection.
LPI,
So that's what this white dust is. If you look, this impeller in particular, we did the dimensional and did 100% dye penetrant testing on it, looking for any cracks in the, a lot of these impellers will get cracks in the vane to hub junctures. We'll repair them. And then this impeller is showing a lot of cavitation signs as well. So what we'll do is we'll grind these out, weld them up, blend them, and then if it's necessary, every pump's different. We'll remachine them. There's been times where we have to weld up the outside diameter of the vanes. We have to weld up the bore. It varies depending from pump to pump. And then final step we'll balance it. We have a balancing machine which we'll show you as well.
One time I was in a place out in Philly, a Derbyshire machine. They make like a lot of Navy stuff, whatever, a lot of valves.
Yeah.
But they were pressure testing this valve to see if it held fluid or whatever. And it just looks like a solid chunk of metal.
Yeah.
And there's water pouring out of it.
Yeah.
Like it had some crack that you couldn't see.
Yep.
And it was just dumping water out. It was like the craziest thing. It was like Moses struck the rock in the desert or something. It was crazy.
A lot of parts that we do here require hydro testing as well. So
And you do that on site?
yeah, we'll do that on site.
These like fixtures that you can.
Yeah,
tell
this
me
is
what.
positioners. What these do is they tilt and they go around. So you can put your part on, say on top of that, weld it down, and then it can go down to a 90, and then you can weld when you're in good position.
Okay.
We call them positioners. The position to weld.
Right. Yeah,
But,
instead of
yeah.
hooking it to a crane and trying
Yeah,
to flip it. And,
Yeah, and you could this way you can with your gun you can just sit there and more or less just kind
You're
of dump
flat
wire
welding,
in
basically.
in the joint.
Yep.
Right.
Okay.
Gotcha.
And that's our oven.
Oh.
That's our stress relieving oven in there. But it's running right now.
Yeah.
But
Probably don't want to go in there.
yeah, no.
No, it's a little warm.
No.
It's a
What'd you say,
little-
like 1200 degrees or
Yeah, this one's 11. No, this one's
750.
700. Yeah, 725.
725. Yep.
Yeah, right now this procedure is 725. But that's 10 foot by 30 foot, I think, by 10 foot high. So we can put big pieces in there.
Yeah.
Chuck Parker,
Chuck. That's right.
Yeah.
Chad.
the president. So a little bit of everything. Wear a lot of hats.
Nice.
IT.
Yeah, yeah. I always tell people when they ask me what I do, work on turbines to toilets.
Okay.
And everything in between.
A lot of the same technology in a turbine and a toilet, right? You got fluid
Hey.
flow and
Yeah.
Fluids, as long as it has fluids, pipes, and wires, we're
He's
good.
in.
We're in.
sounds good. I'll keep that in mind when I get a clog.
Yeah. In here we have our paint booth. So all finished material, whether it's coming out of machine shop or fab shop, it'll go into here. You know, as you can hear, they're spraying right now, so they have the exhaust fans and whatnot going. But we do all of our painting in there. and then it'll come out and be dispersed to whether it's shipping or if it's coming over for assembly, which Chuck and Andrew will be able to go over with you shortly. You know, that's another impeller there that we are doing for a wastewater facility.
Okay.
That's a sewer plant impeller. I wouldn't touch it.
Yeah, and you can see that paint booth is this whole section, and it's, what, about 10 or 12 foot wide? Maybe even wider than that, I think. Yeah, maybe 16. So it's very large. We can get large base plates in there and that kind of thing.
Over here we have our shank balancing machine, so we'll balance rotors and impellers.
So it spins it, senses where the out of balance is.
Yeah, yep. So we have a shaft. We have multiple shafts, and then we build bushings based off of the size of the impeller or the rotor. You know, with in this case an impeller. We'll machine those bushings, mount them onto the shaft, drop the shaft into the impeller, turn it horizontally, and then it'll ride on these bearings. These bearings have sensors in them and can determine where the out of balance is. It'll come up onto the computer screen, and then we'll do all the correcting. 9 times out of 10, we're grinding.
Okay.
We're either grinding or we're air arcing material off, carbon arc gouging material off, and then grinding it smooth.
Here's where we do pipe spools. So we fabricate, we fit the pipe spools, and we'll weld them up. So one of our methods for doing system assemblies is to basically do pipe spools prior to the assembly. So we'll design the spools so that when we get the assembly process going, everything just fits right on. And if we may leave a joint or two loose to final fit at assembly, but we'll fabricate the spools, do all the hydro of the spools, and they'll be totally ready to go when we begin the assembly process.
And what type of system is this going on?
It's a mix. Pipe spools are for lube oil systems, for gas seal systems, steam systems, maybe associated with compressor or pump packaging, the piping that's associated with the lube oil supply, drain, seal gas systems. And we do it to the industry standards. There's a lot of API standards that we comply with, ASME standards. Typically for piping, we're B31.3, B31.1 are the industry standards that we fabricate piping to.
Gotcha. Okay. This looks like all stainless stuff.
Yeah, the majority of it is stainless. We do some carbon, but majority is stainless. Typically, it's all radiograph quality. The stainless pipes are all TIG rooted, and then depending on the pipe size, they're either stick or they could be TIG, stick, or flux core for the filler.
Gotcha. So end user of this type of stuff, like who would that be?
The end users are all the petrochemical industries and some power gen. So you're talking like ExxonMobil, Shell, PBF, and others that are like that. So, and then we also engage with the EPCs that are out there, the engineering procurement contractors, and that could be like the Bechtels, the S&Bs, and those sorts of guys.
Yeah, interesting.
Yeah, so this is our assembly shop where we actually put the systems together. So all those piping components get fit into a skid assembly, and we do complete design and fabrication of the base, the layout, the reservoir, all the structural steel we design and fabricate.
Boy, beautiful work.
Yeah. This will be lubricating a motor gear compressor train. And this particular one is actually going down to New Mexico. And it is a replacement lube oil system to an existing older machine. So they have an antiquated machine, not very reliable, has issues. So we actually were contacted by them to provide an upgraded system. And we meet all the latest industry standards as well. It's for just lubricating the bearings of rotating machinery.
Okay.
So
super critical, very, very expensive machinery.
Very expensive. So. And this stuff is all designed to run, service life of at least 20 years, but it's also designed to run continuously without shutting down for an average of 5 years.
Wow.
So 24/7 for 5 years between turnarounds before they'll do general maintenance, shut down the whole facility to do maintenance.
Because if they shut this down, the plant is losing millions and millions of dollars per hour.
Quite possibly, yes.
Okay.
Yep.
Yeah, super critical.
Yeah, so there's a lot of redundancy, backup, a lot of instrumentation to monitor component, the functionality of the system, so that if something is going a little bit awry, they can respond to it before it would actually shut down the machine.
Interesting.
So what a seal gas panel does is for compressors to contain the process gas within the compressor, because typically the pressure is much higher than ambient pressure, and to contain it so it doesn't leak out to the atmosphere, there's a particular type of gas seal that you can inject a clean seal gas into the seal cavity, and it'll provide a barrier to keep the process gas inside the compressor contained so it doesn't escape to the atmosphere. So these systems basically produce clean, filtered dry gas at controlled flows and pressures with all kinds of monitoring instrumentation, so you can evaluate the functionality of the system to keep the gas inside the compressor, the process gas inside the compressor. And that process gas is quite a diverse mix of different applications. Hydrogen to wet gas compressors to CO2. There's lots of different variations that are used in oil and gas industry and also in the chemical industry.
Okay. I mean, these are just beautiful, very visually satisfying how well the stuff is laid out and how neatly it's bent and everything. Nice.
They're very talented.
Yeah.
They're also very meticulous. When they put every tube together, they clean every single one. And any type of particulate could really wreck a machine, so we take a lot of pride in making sure that doesn't happen.
Yeah.
And there's a lot of engineering that goes, like you can take a simple transmitter like this. This transmitter probably has, I'm going to say, no less than maybe 50 to 75 different option configurations that it can have, even though it looks the same as far as the ranges and the materials and certifications that are involved. So we have to actually go through and define all those components down to the details sufficient to satisfy the job.
Yeah. Wow. What is that big box over there?
That's another unit that's going to kind of look like that one when it's done.
Okay.
So it's just in an earlier stage of assembly.
I see. All the piping and stuff is going to go on that skid.
Yep.
And that's the oil is in the big box.
Yeah, that's the oil reservoir. So that they fill that with oil, and then there's pumps that basically pump up the oil that will pull it off the reservoir, pump it up to pressure, and then it gets circulated through coolers, through filters, and then pressure regulated through control valves, and shoots off to the unit. Piping from the unit then brings it back into the reservoir. So it's a recirculation system, continuously recirculating.
Cool.
And we're filtering and cooling the oil as it's being recirculated.
Yep.
So associated with these systems that we build now, we also do packaging of compressors and pumps, which we don't have any in here currently. So those are a lot bigger skids, and we get the big equipment on there, and anywhere from, I'm going to say as small as maybe 800 to 1,000 horsepower, up to 40,000 horsepower units that we've done.
Yeah.
So,
and then you say that's as small as 1,000 horsepower. I was like, that's a lot.
Yeah. The pump sizes that we use for the lube oil, they range from as small as maybe 1 horse up to about 150 horsepower is where our sweet spot is.
Code, Andrew.
Yeah.
Yeah.
Yeah, so we do all Section 8 Div 1 code vessels here as well, various sizes. We've done things as small as 5-gallon capacity to 30-foot tall tanks with platforms and ladders. We do all the calculations in-house here. Recently started getting into nuclear, so we have Section 3 qualified NDT procedures. Did you mention weld procedures? I think we have over 100 now.
Over 60, 160 almost.
Over 160 qualified weld procedures, all for Section 9 that we utilize for code vessels as well. Pretty much just the one-stop shop here, whatever you need.
Yeah, impressive facility.
Plus we have a welding